Good afternoon, everyone. My name is Mahmoud. I'm from the University of Glasgow, and I'm conscious I'm just before the coffee break, so I will stick to time. I will introduce a little bit more about IDs, tracking items across supply chain, tracking and sensing items in particular. And we've just heard from the previous first two talks and even the last talk about bonding and the importance of tracking individual items. And we'll start from some chip-free approaches. We're all familiar with how difficult it is to bond chips in many applications, and then how that might combine with battery-free systems. So we are a research lab at the University of Glasgow. We work across different topics, starting from materials, very similar to what you see outside. But today I'm covering more around the application side and the end use of the systems that we're developing. And the purpose really with a lot of the RFID technologies, the tracking, NFC, Bluetooth, low energy, is so that you can get data from the physical world into digital domain. You can send it wirelessly, and then the cloud can start to process your data. So I've got a very rough plot here of how complex is the thing that you're using to collect the data versus how much data, how much sensing parameters, and maybe how much storage can you put into the item. And the most complex, most powerful item that we can cover today is microcontrollers. They're usually battery powered. They usually communicate over a few hundred meters when you're using Bluetooth and all the antennas are optimized. But they are usually too complex for a lot of the printed systems. And there are examples outside in the exhibition of BLE microcontrollers. They have many components around them to be assembled, not a straightforward process. If you go down in complexity, you get the wireless powered systems. This is something we're developing, and you've heard some of the previous speakers about wireless powered Bluetooth. Again, that's the range where we're either reliant on a battery or a significant radio frequency supply so that you can energize these systems at 10 meters, 20 meters, whatever, but you can ultimately rely on them when you have a strong power supply. And then there was the RFID. It's the easiest to integrate, the most convenient to work with, and the same for NFC, even though that only works at a few centimeters. And you're then working with chips that only have 2 bond pads, so it's very easy to package. The data that you're getting is very limited. Usually just a few tens of bytes or maybe a kilobyte maximum. But then if I go into something that doesn't have any chips, but has the same data encoding capacity of a few kilobytes, and if I tell you that we can fabricate that device using biodegradable material, it's entirely additively manufactured, and it costs less than 1 cent to make, would everyone here be excited about that? Raise your hand if you want a device that ticks these boxes. Anyone happy with that? Few hands, everyone is happy with that biodegradable additive 1 cent device. It's called a QR code or a barcode, and we all have it. It's on these things. You print some ink on a piece of paper. You can store a few kilobytes on that. You just need a camera to read it. It's an optical ID. It's a physical way of storing data, and it ticks all the boxes of being additive, printed, and biodegradable. That's not what we're talking about. Now let's talk about a sensor which cannot store any data. On the face of it, it's completely useless because it cannot identify anything. You can't tell what the item is. But in reality, that is radar. Radar is one of the most used sensing technologies, arguably one of the largest, if not the largest sensing technology over the world. And radar does not have any ID. Radar cannot identify what it's looking at. All it can see is something is moving. So what I'm talking about today is going to be that integration of, it's not a QR code. It's not going to give you the same data capacity of a QR code. But it has the same functionality as a radar. It can track how things move, and it can give you just enough bits so that you can say, what is this, where is it, and then sense it just like a radar would. And we demonstrated that in some sensing applications integrated with some advanced materials, so I'll cover that, and it's an open invitation for you to give us more materials to test with. So why do we want to go chipless? Purely from an environmental perspective and a little bit of cost perspective. If you take a smartphone, arguably a very old smartphone, and you perform a life cycle assessment to see where is the environmental impact coming from, the IC fabrication is usually the biggest component. Everything else, including every day of charging the phone, is relatively insignificant compared to the energy it takes to manufacture one chip. And if you look at where the chips come from, usually they rely on a lot of rare earth metals. Supply chain for that is very complicated, so it's extremely difficult to source the right materials for your devices. So how does a chipless RFID tag operate? It doesn't use a chip. It doesn't have any digital information. But what it does is it responds to a radar-like signal. Your radar sends a signal. It looks for something called a radar cross-section, or RCS.